The final step in the process is storage, and it's all about putting the carbon dioxide away for good. We can't just release it somewhere else. We need to lock it up so it can't get back into the atmosphere. To do this, we inject the captured and transported CO₂ deep underground, usually more than 1 kilometer, or about half a mile beneath the surface. At that depth, the intense pressure keeps the CO₂ in that dense, liquid-like state, making it less likely to move around. The CO₂ is injected into porous rock layers, which are like giant underground sponges made of stone. These are the same types of rock formations that have held oil and natural gas trapped for millions of years. There are several types of underground locations that are excellent for storing CO₂. One of the most common is depleted oil and gas reservoirs. These are old oil or gas fields where we've already pumped out most of the fuel. We know these sites are good at holding gases because they did it for millions of years. Another great option is deep saline aquifers. These are vast layers of porous rock filled with very salty water that is not suitable for drinking or agriculture. They have huge storage potential. A third option is unminable coal seams, which are coal beds that are too deep or too thin to be mined. The CO₂ can actually stick to the surface of the coal, keeping it locked in place. Once the CO₂ is injected, it gets trapped in several ways. First, it's held in place by a solid, non-porous layer of rock above the storage site, called a cap rock. This cap rock acts like a giant natural seal or lid, preventing the CO₂ from escaping upwards. Over time, the CO₂ can also dissolve into the salty water in the rock pores, just like sugar dissolves in water. In some cases, over very long periods, it can even react with the surrounding rock and minerals to form new, solid carbonate minerals, essentially turning back into stone. This is the most permanent and secure form of storage. To make sure the CO₂ stays put, these storage sites are monitored extremely carefully. Before a site is even selected, geologists study it for years to make sure it's stable and secure. Once injection begins, scientists use sensitive equipment to monitor everything. They use seismic sensors to listen for tiny tremors, sample groundwater from nearby wells to check for any changes, and even use satellites to detect any tiny movements in the ground surface. This constant monitoring ensures the storage is safe and permanent, protecting our environment for generations to come. It's like putting the carbon back where it came from, deep within the earth.